Okay. Now today's session, I will going to discuss about a few concepts from the purpose of embedded system. I was explained in the last class. Now today I will continue from these purpose of an embedded system. So last class main four parameters to be discussed. Am I right? Yes or no? Up to monitoring. Hello. Is it audible?
Yes, sir. Audible.
Yes, sir.
So last class
Yes, sir.
we
Audible, sir.
ಎಲ್ಲಿವರೆಗೂ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ರಿ ಅಪ್ ಟು ಮಾನಿಟರಿಂಗ್ ನೋ
Yes, sir.
ಓಕೆ ನಾವು last class we discussed up to that monitoring. I mean that first one is data collection, storage, representation is a good example for digital camera. Second one it is data communications. In the good example in the data communication we used routers, internet routers, and data processing. We can some of the electronics gadget used for communicating or processing the data, and the monitoring we use digital CRO, all these things. Then next we'll come to the control. So here the control is one of the important parameters in any embedded system. So we'll consider one example. It is a air conditioners. So these air conditioners, it is a good example for controlling the embedded system parameters. Means to control the temperature from minimum to the maximum. So what about the temperature have in our environment? First we are going to check it and record it. Then based on our requirement we are going to set that temperatures. Suppose our room temperature it may be 28 degree, but based on our requirement maybe we need 23 degree. By the time we are going to set that. So air conditioner is one of the embedded system used for control purpose. That is what the purpose of an embedded system, to control the different temperature levels. Okay, here in this control system we can use both sensors and actuators. Sensors is nothing but input, actuators is nothing but output. Now the sensors are connected to the input port of the capturing the changes in environmental variables or measuring variables. And similar way, the actuators connected to the output port are controlled according to the changes in the input variables, and it will affect to that impact for that. And these air conditioners for controlling room temperature is a typical example for embedded system with control functionalities. Okay, the air conditioner contains a room temperature sensing the element by using the sensors, which may be a thermistor and a handheld unit for setting of the desired temperatures. So means that the overall conclusion for these air conditioners, the air conditioner is one of the embedded system. We are going to adjust the temperature based on our requirement. That is what the purpose of the control unit or control the embedded unit. So after these control units, we have some more application specific user interfaces are available. The one good example for application specific user interface, it is cell phone. This cell phone, it is designed for only the specific purpose. But along with these, some more parameters to be included. So what are those parameters? We have this cell phone, along with we can use the camera is another parameters, and sometimes some more additional communication purpose we are using, because some smartphones only they are going to use some advanced digital environment, but others other than smartphone they are not support for that. Okay, so someone is controlling these, they're trying to control, please don't try now, we can try it later. Yeah, so here I think someone has tried something, please don't do during this class. So once tracked, it will take some amount of time to come back. Just a minute. Okay, here this cell phone is designed for only the specific applications. So it contains application specific user interface like keypad, display unit. So mainly in the cell phone we have keypad. It may be a smartphone or it may be a other than smartphone, and the display unit. And the display unit, keypad and battery, it will take more space. If it is in the smartphone, we are not worrying about the keypad. Only we are looking about the screen and the battery. And it is a target to the some only the set of users, group of users only we are targeting for that. Some additional features what we implemented in the cell phone. And some of the cell phones we are used to control in industrial application also in advanced things. And along with that, the application specific embedded system used in the smart running shoes from the defined company. One of the company introduced that the Adidas, the innovative bonding of lifestyle with embedded technology. These shoes developed by Adidas, which constantly adapt its shock observing characteristics to customize its value to the individual runner depending on running style. And here it was designed. The sensors were fixed at the bottom layer of the shoes. This is what the designed, even based on the uh, where we are going to use, means where we are going to utilize to run this, and the body weight, the weight of the body also it will be considered. Based on these two parameters they are going to design it. Suppose the surface is not clear or its weight is unbalanced, during that time the embedded system is not support for perfect readings for that. So means that I want to count number of steps, number of meters or number of kilometers to run. Everything it will be recorded through this kind of sensors. But the sensors have some restrictions. The restrictions is nothing but the surface and weight also is the one of the important parameters. And these sensors to sense that input signal, and the actuators and a microprocessor unit which run the algorithm for adapting the shock observing characteristics of the shoe. It means that the input input is sensors, output is actuators, and the microprocessor unit we can use some kind of algorithms for adapting the shock observing characteristics of the shoe. And the micromotor actuator controls the cushioning as per the commands from the microprocessor unit. MPU is nothing but microprocessor unit. But here one thing I'm going to clarify. In this concept, we are going to process either we can use for microprocessor or microcontrollers. But the technology is available. Based on the cost and based on the requirement, we are going to design it. One thing is we have to use the sensors. Second one is actuators. Then microcontroller unit we are going to use. Either microcontroller unit or microprocessor unit we are going to use to record the number of kilometers you run from one place to the another place. We can measure that and we can count the number of steps also. Suppose we want to reach 1 kilometers for 5 minutes or 10 minutes, how many steps, everything it will be counted. During these, some real time computations they are going to use how many steps and how many kilometers and what is the time durations. Everything we are going to measurable. So means that this embedded system it support for all these kind of applications. But the last one it is application specific. Based on user requirement they are going to design. It is not a constant. So other than these, the remaining purposes are defined. Example, it may be communications or it may be a monitoring, control and all these things. But here, based on the requirement we are going to use, that is what they are going to conclude the purpose of an embedded system. Okay. So now I'll go to the next part of the embedded system here, the core of an embedded system. The core of the embedded system falls into any one of the following categories. Mainly we have four categories. Out of these, we are going to use any one core part. That core part is nothing but it may be a general purpose and domain specific purpose or programmable logic devices, PLDs, and then application specific integrated circuits. The last one is commercial off the shelf component. These are the core of the embedded system we are going to use. Now in this chapter only we discuss only these are the core part of an embedded system we are going to discuss in this module. Okay, in the remaining 5 to 6 hours I'm going to explain only about these core parameters or core of an embedded systems. Okay, now we'll start with first one in general purpose and domain specific purpose. In general purpose and domain specific purpose we have three parameters: microprocessor, microcontrollers and digital signal processing, DSPs. In this today's class we're going to discuss about microprocessor and microcontroller. So once comes to this part, general purpose processor and application specific instruction set process. So the same concept I'll already explained many times. How application specific processor is different from the general purpose process. So I'll give you overall information about to this slide. So in general purpose process, they have only ALU and control in it and some of the registers. But comes to the application specific process, we can use some set of instructions to optimize the specific applications. But in general purpose process, only the general applications, not specific application. But the advantage by using the general purpose process, we can make it to develop any other particular purpose, any other, sorry, not particular, any other purpose. We have the core part, we can utilize that core part, we can go for more than one applications we are going to develop it. But application specific instruction is not like that. We have to prepare some set of instructions. We have to execute as per our requirement or optimize to specific applications. Okay. For example, these application specific instruction set process are network processing. They are defined very clearly related to the network processing. That is what network processing, automotives, telecom, and media applications, and some of the processing, DSP, digital processing, and the mainly you can use for control applications. We are going to control some of the operation. Example, in our vehicles, ABS system is available. It's one controlling system. This is what one specific applications. For these specific applications, you have to write specific instruction set for that processor or that controllers. Okay, and these are some specific purpose. We are going to use some kind of microcontroller or maybe some kind of microprocessor. We have many different types of microprocessor and microcontrollers are available. We can use either 8-bit microcontroller or 16-bit microcontroller or 32-bit microcontrollers. If it is 8-bit microcontroller, you can go for 8051 microcontroller. If it is 16-bit, or if it is 32-bit microcontrollers, if it is 16-bit, you can go for Atmel. If it is 32-bit, you can go for ARM process. Example, what we studied in module 1 and module 2 is a Cortex M3 processor. It belongs to that mainly target into the 32-bit process. But some cases or some applications we can use as a 16-bit process, because in ARM processor we have two modes of operation. One is ARM mode, another one is a thumb mode. If it is a thumb mode, 32-bit operation. If it is ARM mode, is only 16-bit operations. So likewise, we are going to design. That is what general purpose and specific purpose or applications. Now we'll come to that brief about the microprocessor. I think all of you are aware of that. In the first few classes, I'll explain what is microprocessor and microcontroller. With respect to the embedded system, just I'll brief out into that. The microprocessor is a CPU. The CPU is made up of ALU, control unit, and some of the registers. But processor, it only the process. But microprocessor is a dependent unit, because without additional or external components or device, we can't run it. If you want to run the system or you can implement in the any product or any project, we can't use microprocessor independently because it's a dependent process. We can use addition to that memory unit, control unit, timer unit, interrupt unit. All these things we are going to use it. If you want to become a proper functioning of that product, the microprocessor along with the additional components or additional blocks we are going to use. For example, memory unit, timer unit, interrupt unit, and some of the hardwares. Circuitry also we are going to use for that. So example, in the microprocess, we have discussed in the survey of microprocessor also. It will be started from 4-bit microprocessor to the 32-bit microprocess. 4-bit 4004 processor, 8-bit 8085 microprocessor, it belongs to the 8-bit process. 8086, it belongs to that 16-bit microprocess. Like that, many more different bit configuration processor available. You can use based on our requirement or based on our applications. That is what the overall view of microprocessor. But the microprocessor, it only the process. You don't have controlling unit in this microprocess. For example, you can take your vehicle, the accelerators. The accelerators only you can increase the speed of your vehicles. That is what the process. Okay, you can increase the speed or we can decrease the speed. Decrease the speed, you don't have any other options. Only you can release the accelerators. You can press the accelerators, keep on increasing. The speed is increasing. If the accelerator pedal is release it, the speed will become decreasing. That is what the process. The processor only can process it, but you don't have control in it. If you want processing and controlling unit, can go for the next the device. It is called as a microcontroller. The microcontroller is very essential nowadays for almost all embedded system. You can use microcontroller part. This is one basic devices available. Based on our requirement, we are going to use either 8-bit or 16-bit or it may be 32-bit microcontrollers. The many industries, they develop different kind of controllers. Maybe 8-bit or maybe 16-bit or 32-bit controllers in the different Motorola, Intel, like many industries, they develop such kind of microcontrollers for real-time applications. So these microcontrollers are highly integrated chip. Integrated chip is made up of microprocessor along with memory unit, maybe a program memory or it may be a data memory. Then timer, interrupt control unit, and some of the dedicated input output ports. These are all things is inbuilt into that devices. And the microcontroller can be considered as a superset of microprocessor. So many microcontrollers are available. We list out in the point number 3, like Intel 8051. Okay, the AVR for automotive AVR from Atmel corporations. We have like that based on our requirement. We are going to use for that. And if you come to the microcontroller, we have some more advantages. The Texas also introduced some controllers. They're not called as a microcontrollers. They're called as a controllers. It may be a DSP controllers also they used. Texas Instrument. That is what the name of the controllers or name of the processor will be called as a TMS process. That is what developed from or developed by Texas Instruments. If you come to these microcontrollers, we have more advantages. For example, they become cheap, like cost effective, and uh, it is easily available in the market. This is what the microcontroller, it will become easily available in the market. We can implement, and the cost is very cheap compared to others. We can use even simple toys to the some higher end application also. Higher end application is nothing but in today you can use for real time operating systems also. By the time they helps to control some of the main applications are in the real time applications. Okay, this is what the microcontroller part. Now just a brief out to that comparison between microprocessor and microcontrollers. So in the first module, I given the notes also for this microprocessor and microcontrollers. So am I right? In the first introduction part, module 1, I'll given all these details. I explained during the time only. Are you agree? Please someone
Yes,
to
sir.
respond for this. Huh? ಯಾರೋ ವಾಯ್ಸ್ ಕೇಳಿಸ್ತಲ್ವಲ್ರಿ? Hello. It's not audible.
Yes, sir, it's audible.
Yes, sir.
ಏನ್ ಮಾಡ್ತಾ ಇದ್ರಿ? ಯಾರು ಸೌಂಡ್ ಇಲ್ವಲ್ರಿ? ನಾಟ್ ರೆಸ್ಪಾಂಡೆಡ್. ಸಿಆರ್
Audible, sir.
ಆಡಿಬಲ್ ಇದೆಯಾ? ನಾನು ಫಸ್ಟ್ ಮಾಡ್ಯೂಲ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದೀನಲ್ಲೇನ್ರಿ ಆಲ್ ದಿಸ್ ಇನ್ಫಾರ್ಮೇಶನ್ಸ್ ಅಲ್ಲಿ ಪ್ರೊವೈಡೆಡ್ ಡ್ಯೂರಿಂಗ್ ದ ಟೈಮ್.
Yes, sir.
ಫಸ್ಟ್ ಕ್ಲಾಸ್ ನೋಟ್ಸ್ ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗುತ್ತೆ ನಿಮ್ಗೆ, ಕೊಟ್ಟಿದ್ದೀನಿ ಸೇಮ್ ಕಂಪ್ಯಾರಿಸನ್. ಸೊ ಮೈಕ್ರೋ ಕಂಟ್ರೋಲರ್ ಇಸ್ ಡಿಫರೆಂಟ್ ಫ್ರಮ್ ಮೈಕ್ರೋ ಪ್ರೊಸೆಸರ್. ದಟ್ಸ್ ಇಟ್. ದಟ್ಸ್ ವಾಟ್ ದ ಇಂಟೆನ್ಷನ್ ಆಫ್ ದಿಸ್. ಸೊ ಇನ್ ದ ಚಾಪ್ಟರ್ ಆಲ್ಸೋ ಆಸ್ ಪರ್ ದ ಸಿಲೆಬಸ್ ಇಸ್ ಮೆನ್ಷನ್. ದ ರೀಸನ್ ಇಸ್ ವೆರಿ ಸಿಂಪಲ್. Before going to design an embedded system, the designer have to survey which one is better? Either the microcontroller is better or it may be microprocessor is better. That is what the intention of that. Before going to select that, you have to compare some parameters. What way if you selected microcontroller as a good device, just you have to justification for that. What way microcontroller is better than microprocessor? That is what the intention to compare this. But usually even microprocessor also is a more flexible than microcontrollers. Please remember this point. It is very important. It is applicable in many areas. Microprocessor is more flexible than microcontrollers because we can modify. The option is available to modify little bit based on our requirement. We are going to modify, but microcontroller we can't modify it. Everything is inbuilt. For example, 8051 microcontrollers, you don't have analog to digital or digital to analog converters. Am I right? Inbuilt ಇದೆ micro 8051 microprocessor ಓದಿದಿರಲ್ಲ 4th semester inbuilt ADC ಇದೆಯಾ device analog to digital, digital to analog conversion is not there. Am I right? Rakshit R, Rakshita K and Rakshit R, they are not there in the class.
Yes, sir.
Rakshita, where is Rakshit? Rakshit is not responded.
Sir, yes, sir.
Hmm.
Yes, sir.
Yes. ಏನ್ ಹೇಳ್ತಾ
Unmute
ಇದೆ ಹೇಳಿ? ಏನೇನು ಹೇಳ್ತಾ ಇದ್ನಲ್ರಿ? 8051 what you studied in from 4th semesters, that controllers don't have analog to digital, digital to analog converters inbuilt. But some applications, suppose we required digital to analog conversion and analog to digital conversions. If you selected as a microcontroller 8051, but it not support for that. That is one drawback. So by the time you can go for some other controllers. That is what the drawback in microcontroller. But in microprocessor, we can use additionally analog to digital converters also is one of the part of microprocessor. Or additionally, we can connect to that microprocessor. That is what is more flexible than microcontrollers. If everything is inbuilt, no problem. If it is not available, during the time only we are facing the problems. Okay, once please go through this slide. Okay, first point with respect to the definition. Second point, it is respect to the inbuilt devices. So microprocessor is a dependent unit. It requires the combination of other chips like timers, programs and data memory chips, interrupt controllers, etc. for functioning. But in case of microcontroller, doesn't require any external interrupt. Everything is inbuilt. And point number 3. So most of the time general purpose in design and operations. So most application oriented or domain specific in microcontrollers. Okay, these are the difference between microprocessor and microcontroller. Some more difference already I explained during the module 1 only. Okay, so now next class we'll go to the some more information about the domain specific devices, domain specific process or controller, and then some of the sensors, memory part, actuators, all these things we are going to cover. Probably another 5 minimum 5 hours to require these module. Okay. So any doubts from these today's class?
No, sir.
No, any